The Himalayas are the highest mountains on Earth, and they are still growing taller every year. But the rivers that slice through them, the exact rivers that create the Ganga, are actually older than the mountains themselves. Geologists call this antecedent drainage. Millions of years ago, as the Indian tectonic plate crashed into Eurasia, the ground began to rise. But these ancient rivers were already flowing here. Instead of changing course, they acted like a massive geological buzzsaw. As the tectonic plates pushed the rock up, the water eroded it down at the exact same rate, keeping its horizontal elevation constant. If we trace that erosion all the way to its source at Gomukh, high in the glacial ice, we don't actually find the Ganga. What emerges is the Bhagirathi. It begins as a violent torrent of glacial meltwater, tearing its way through solid rock. This entire 2,500-kilometer system functions as a massive kinetic engine, one governed entirely by the interplay of extreme altitude, gravitational pull, and tectonic friction. While the Bhagirathi carves its way down from the west, the true backbone of the system lies to the east. The Alaknanda River actually carries a significantly larger volume of water, acting as the main conveyor belt for the mountain's runoff. As these high-spade mountain rivers navigate the steep slopes, they inevitably collide within deep, narrow valleys. In India, these collision points are called prayags. They are sites of massive kinetic energy release, where millions of gallons of water, rocks, and glacial silt slam into each other. The climax of this mountain assembly line happens at Dev-Prayag. Here, the blue-green water of the Bhagirathi violently crashes into the muddy, silt-heavy flow of the Alaknanda. The two bodies of water churn together, doubling the total volume of the channel. Only after this specific, violent mixture of water and sediment stabilizes do we get the river's true identity. This exact coordinate is the functional birthplace of the Ganga. The river maintains its destructive velocity until it reaches Haridwar. Here, the steep Himalayan gradient vanishes, and the water suddenly hits the flat plains. Its kinetic energy drops immediately. This deceleration completely changes the river's physics. Without the speed required to carry heavy boulders and sediment, it stops eroding rock and aggressively begins dropping millions of tons of silt onto its own riverbed. This sudden drop in speed causes a dangerous anomaly. When the Kosi River flows down from Nepal, it carries massive amounts of Himalayan debris. As it hits the flat plains, the water slows and that heavy sediment immediately drops to the bottom, effectively clogging the river's own channel. With its main path blocked by debris, the tremendous water pressure forces the river to break its banks and violently forge new paths sideways. This rapid, unpredictable displacement swallows entire villages and fields overnight, earning the Kosi its title, the Sorrow of Bihar. While the Himalayan rivers fight deceleration in the north, the tributaries arriving from the south present a completely different geographical puzzle. The general slope of the Indian peninsula tilts downwards to the east and west, yet the Son River manages to flow hundreds of miles straight north, seemingly defying the local gradient to reach the Ganga. Gravity isn't being defied here, it's being redirected by an ancient rift valley. This deep fracture in the Earth's crust created a localized downward slope that pulls the Son River north, overriding the general tilt of the peninsula. Whether it's bringing catastrophic floods to Bihar or pulling water across a fractured peninsula, the Ganga's behavior across the plains is dictated entirely by sudden shifts in velocity and hidden tectonic scars. After absorbing countless tributaries, the swelling river reaches West Bengal, where it does something highly unusual for a main artery. It splits. A massive portion of the water breaks off southward to become the Hooghly River, while the remaining main channel continues into Bangladesh as the Padma. This split marks the beginning of the delta phase. As the river gets closer to the ocean, the slope of the land drops to absolute zero. The kinetic energy that started high in the Himalayas is now completely exhausted. Without the momentum to push forward, the river drops the last of its heavy cargo, millions of tons of silt, clay, and sand. The water literally builds a wall against itself. To reach the sea, the river has no choice but to fracture into dozens of smaller, capillary-like streams to navigate around its own debris. Meanwhile, the main Padma Channel pushes into Bangladesh, where it collides head-on with the Brahmaputra. This merger creates the Meghna, an unimaginably vast wall of water moving steadily toward the coast. This colossal network finally disperses into the Bay of Bengal, dropping enough sediment to build the largest delta on Earth. Here, in the Sundarbans, dense networks of spiky mangrove roots anchor the mud, creating a natural fortress that protects the subcontinent from ocean cyclones. This 2,525-kilometer geological timeline functions as the subcontinent's primary sculptor, a force that endlessly erodes, transports, and rebuilds the Earth itself.